Alrighty, welcome everyone to the second part of our polynomial video. Should have my pencil ready here, but I didn't. So we're just continuing on here with the vocabulary and then some more practice problems, kind of just like that last video, and hopefully getting to the point where the homework is ready to go. So the homework was just factoring practice on this one, so I'm going to go ahead and copy that. I don't know when that homework's going to be due, how I'm going to do it. I'm only supposed to do 2 assignments a week, and the way that I ended up setting this up, it ends up being 3 assignments, so I'm not going to do that to you guys and give you even more extra homework. So probably it's going to be next week's first assignment. The homework will be, I don't know. I haven't fully worked that out yet. But for now, let's just continue these notes. Let's get them done. Let's take those, pictures of the notes when you're all finished, and hopefully you're understanding. And if you got questions, you can ask for it. I will officially be setting up a WebEx tutoring coming up for today. Not today, Thursday and Friday. Actually, I might do it today. I don't know if I'm gonna have time. We have a staff meeting at 2, so we'll see. All right. So our next definition, we got to keep on doing some stuff here. Because the next definition relates to the previous one here, I want to go over what we talked about in our last video really quick. So first of all, we have polynomial. Polynomial is this guy up here, and he looks like this. And polynomials have zeros. Roots or zeros are x values that make the whole polynomial equal to 0. And we did a practice problem like this. We did it here. Where we said, are these guys zeros? And we plugged in like 3 into this problem. And we plugged 3 into the question. We ended up getting 0. So we said 3 is a 0 of f. But then we plugged in 0 and we got 18. So x equals 0 is not a 0 of f. This next definition has it ties directly into this. So the word that we're going to be looking for is the word factor. And the word factor, what this means is the easiest way to state it. What color was I using? So I was using red yesterday. I found this cool pink pen, so I'm going to switch over to pink. So the deal is, we would say that if x equals k is a 0, or a root or a solution, of a polynomial, then we would write x minus k is a factor. So that is the key concept here. So basically, if I just subtract that x minus k over, I take this k and subtract it over to the other side. It's kind of like as if I was, switch color again. If I were to just like subtract k to the other side and make this equal 0 here, that left-hand side is the factor of the question. I also want to note a second part of this, because there is a second definition. If you have a fraction for this guy, so if you had x equals k divided by a of a fraction instead, then the factor is going to be a little bit different. You actually have to basically, it's the same concept, but you can't just subtract it over. You actually have to multiply the a up to the top first. Maybe I should have written that better. If you aren't writing in pen, you can rewrite this way. If you are writing in pen, no big deal. Just do what I'm doing there. You want to multiply the a up here first. And then ax minus k is the factor. Oh my gosh, I cannot spell right now. Okay, so we have all these guys. So we have ax minus k is the factor. That says factor. That is so terrible. I apologize, guys. All right, so we have, if x equals k is a 0, then x minus k is a factor, and x equals k over a. Ax minus k is the factor. A little bit annoying, but all these guys are written in this way. Okay, let's continue on. So the next version, how I want to do this, because I just go to the next page. Just be paper killers here. If you want to do it right in the backhand side of yours, that's fine. If you got a new page, that's awesome. If you're writing smaller than I am because you don't have wide ruled, that's cool too. It's just however you're doing it. We got another definition. The definition here is called factored form. In a factored form of the polynomial, there are a lot of different ways that it could show up. So factored form is anything that ends up looking like this for a polynomial. It's when you have capital A, n, so that very first, the same exact leading coefficient as our previous part of the question. Man, I'm not doing a good job teaching right now. I apologize. I want to go back to this. So we have this polynomial. The very first guy here in front is called our leading term, our leading coefficient. So like yesterday, you do not need to write this down, just like an extra example. If I had like 3x squared minus 4 or something like this, our leading term is this 3x squared in front. The leading coefficient is 3. If you are doing the factored form of this, that guy is still the same. Nothing changes there, but the rest of it does change. So the rest of it is K1, and it actually doesn't have to be written exactly this way because you technically could have a number in front here. So, you could have, it could be like bx minus k. This is just one way of saying it. To make a long story short, you have parentheses written around the entire dang polynomial so that everything is factored. Every single one of these guys also has a possible exponent. So you could have a squared or something like that. And these exponents here are called, they have their own vocab word for it. They are called the multiplicities of these factors. And we have a last definition to part of this. It's not really exactly this definition. It combines with another definition, so we're going to write it in pink, and that is if you add up all multiplicities, that is to say, if you add up all of these question marks here, they end up equaling the degree of the polynomial. So that was a lot of information that probably didn't make very much sense at all. I'm going to do my best now to do some example problems so you can actually get what these words are. So the example problems, again, I'm kind of doing on my notes page. So I would have just kept on doing them here. Unfortunately, I have no more room on this page. So if you were doing it the same way as I was, then you're not going to have any room either. So I'm just going to start up a new page for this stuff right here. You do not have to start a new page. You can continue doing it however it is that you want to do it. I'm just tree killer number 1 right now. So I'm going to say factoring and multiplicity examples is what I'm going to title this one. Okay, so the factoring and multiplicity examples, I'm going to start off by what I'm asking for in one of the questions. I'm doing this actually a different order, by the way, from the notes that are posted on Google Classroom. I'm going to be doing it different direction. So here are the first examples. In the directions, I'm going to say based upon previous definitions, state each 0 the total degree, state each 0. Why did I say that each 0? Yeah, state each 0, the corresponding multiplicity. That's what I forgot to write. Corresponding multiplicity. Holy multiplicity. That word is so hard to spell. The total degree and leading coefficient. Okay, so here we go. Number 1. We have f of x equals negative 5x times x plus 2 cubed. All right, so the first thing we have to do is state each zero. So there are actually 2 zeros in this question. To make a long story short, every separate parenthesis will have its own 0, and if there's an x on the outside, it's also 0. So the zeros in this question, which I'm going to do a capital Z of, the zeros are x equals 0 and x equals negative 2. It's the opposite of whatever's on the inside of this guy. Remember, the definition of a 0 is when you plug it in, you get 0. So if I take negative 2, if I made negative 2 there, negative 2 plus 2 is 0. So that's why it's a 0. You also need to state the multiplicities of these zeros. So the multiplicity of this 0, we would say, I'm going to write m equals, and it's a 1. The reason why is because my exponent here is a 1. Likewise, the multiplicity of this negative 2 is a 3, because the exponent of that factor is a 3. Let's try this all one more time. Let's just say these words, get this all down and understood. So we have factors. That is what this is. This is in factored form. We have something here. If it makes you happy, put parentheses around it. I don't know. And each one of these factors has a 0. So this one has x equals 0. In fact, whenever x is in front, it will always just be 0 out there. This one is negative 2, because if I plug in negative 2, I get 0. Each factor has a multiplicity. So each 0 has a multiplicity. It is the exponent of the factor. So this guy, x equals 0, has an exponent of 1. It's invisible, so the multiplicity is 1. And this guy has an exponent of 3, so its multiplicity is 3. The total degree is when you add up all the multiplicities. So this one has an overall degree. We could say a degree. I don't know why I switched to purple, but I did. So it has a degree of 4. And the leading coefficient is just going to be the number in front, usually. So we could say the leading coefficient in this problem is negative 5. And therefore, I didn't actually write this as part of the actual problem, but I'm going to add the actual problem. I want the leading term and the leading term. So I'm adding that in later. The leading term, therefore, is the combination of these two things. It is a negative 5x to the 4th, would be that leading term. It's a little bit weird, but to make a long story short, if I multiplied this all out and I actually did all the distribution and figured out what this thing is, I would get an x to the 4th in the question. I know it's hard. We're doing 4 examples total. I'm going to do one more for you guys where I don't tell you to do any of it on your own, but I would like you to try the actually the numbers 3 and 4 more on your own before you watch the whole video for it. So number 2. We have f of x equals 2, 3x minus 2 squared times x plus 4. Okay, so again, same exact idea we want to do first. The first thing is to state the zeros. So the first 0, do not get tricked. Don't think there's a 0. There's no x in front of this. So because there's no x there, there's no 0 for that. But there is a 0 for this. The 0 here, because this is 3x minus 2, what makes that equal to 0? If you can remember the previous page's definition, you can immediately simply realize that it's 2 over 3 is the 0. If you can't memorize that definition where you have the x equals k over a, that whole thing that I was showing there, you have another option. A little tiny bit of work, but really not that much work. I'm going to do that work off to the side. If I do 3x minus 2 equals 0, and I solve this like an Algebra 1 question, I'll get to this 2/3. I add 2 to both sides. And then divide both sides by 3. And you get x equals 2 over 3. So I get the same exact thing, but if you can memorize the definition that it's, hey, it's this guy over this guy, change the sign. Could be a little faster for you, up to you. So we have x equals 2/3, and we have x equals negative 4 are my 2 zeros. The multiplicities of those zeros. The multiplicity of this 0 is 2, because it has an exponent of 2. The multiplicity of this one is 1 because there's an invisible 1 here. That means the overall degree of the problem is 2 plus 1 is 3. The leading coefficient. This one is tough. So the leading coefficient of this one, I'm going to give it away, and then I want you to try to figure out where the world it came from. 18. Why is it 18? So you'd think it was 2, but it's not. The reason why is that if I multiplied this out, I would have this 3x here would end up being multiplied out twice, because I'd have a 3x, and then that squared means I'd have 3x again. So it's kind of like the leading coefficient, the leading term, is going to be 18x cubed. And the way where that came from, if you wanted to kind of do it, I'm going to go ahead and do some purple action, or some blue action here. I'm going to circle a bunch of stuff. The leading, maybe I should circle that too. The leading term, where that came from, would have been 2 multiplied by 3x squared multiplied by x to the 1. So it's kind of like I forgot about whatever the rest of the factor is and only did the first thing for every single one of these. And if I did all this work out, I'd have 2 times 9 is 18, and then x cubed. So, not, again, the easiest question in the world, but we're getting through. We're going to make it through. We're going to continue on. We got to go on to our next example, number 3. Same exact process. So, again, once I've actually written this up, I am going to ask you to pause. And I want you to try to do as much of the question as you can on your own. Because if you can get used to these definitions and treat it like a regular class time where I would have said, okay, everyone pause, and I would like you to try some whiteboard practice problems. If you're treating this like a whiteboard practice problem where I'm checking, hey, okay, yes, you did it right. Hey, you did it right. You can actually see if you're learning this stuff instead of just copying it down. If you feel like you need to, at this point in time, one of the benefits to having an online class is you could say, you know what, I didn't really get what Mr. Richards was talking about there. I can go and rewatch it right now. If you're really also not understanding, you could technically just continue watching the video and just let me do the problem for you. But I would love for you to actually try to understand it, do it on your own, because I don't have like even more of these practice problems quite yet. That's not where the homework is. But you need to know how to do all these things for the rest of the stuff that we're going to be doing with polynomials. So again, what am I asking for? I'm asking for zeros, the total degree, leading coefficient, leading term. Pause the video, see if you can do the problem on your own. All right, there's your chance to pause it. If you didn't pause it, life goes on. If you did pause it, here, you're checking your work. So we have zeros. First 0 is x equals 4. The second 0 is x equals -2. The multiplicities of those zeros. The multiplicity of the first 0 here is 3, because it's exponent of 3. Multiplicity of the second 0 is 2, because it has exponent of 2. The degree is therefore 5. I'm going to run out of room on my paper here. The leading coefficient is -1 because there's a negative in this invisible 1 right there. And last but not least, my leading term is therefore negative x to the 5th, or -1x to the 5th if it makes you happy. All right, so there are the first 3 examples there. I'm totally running out of room because I have a 4th example to do for this type, so let's just keep on going. Hopefully you got that right. And again, I would love for you to pause after you've written this next one down. And yeah. So continuing on, number 4. We have g of x equals 2 5x plus 1 squared times x plus 7. Okay. So, again, the first thing you have to do is find the zeros. So the zeros of 5x plus 1. Oh, by the way, you should be pausing the video if you haven't already. Okay. There's your chance. We have x equals you can just use the definition. Definition is this guy over this guy, change the sign. -1/5. Again, if that's too much for you, just do 5x plus 1 equals 0 and solve this like an Algebra 1 question. Subtract 1 on both sides. Divide both sides by 5 and you get -1/5. Not too bad. Okay. And you also have x equals -7 as a 0. This one has a multiplicity of 2. This one has a multiplicity of 1. And then after that, overall degree is 2 plus 1 is 3. The leading term in this problem, this one, or leading coefficient first, sorry. And then leading term. The leading coefficient, again, you have to consider this 5 that's getting squared here. So leading coefficient in this question is 50, because it's 5 squared times 2. And then the leading term is therefore 50, and the degree is 3, so 50x to the third. All right, so those were this type of example. Now we're going to go the backwards type of example. Isn't that wonderful? I think it's wonderful. So I'm going to keep on going with it. So we have, it says, based upon the above definition, we want to create a polynomial in factored form. So create a polynomial with the given properties. And the properties I want this time are zeros of x equals 2, -2, and 5, and I want all different multiplicities. An overall degree of 8, and a leading coefficient of -7. So I want all these things to be true for this polynomial. So you have to create one. So I'm going to create a letter. I'm going to choose z because I like the letter z. Z of x equals, and I need to do all these things. So leading coefficient needs to be -7. So I'm just going to go -7's in front. Nice. So we can do that first. Please note, you can't just do that if any of these are fractions. If any of those are fractions, you got some work cut out for you. But no fractions in this one. And we have zeros of 2, -2, and 5. So 2 means x minus 2, -2 means x plus 2, and 5 means x minus 5. So I did 2 there, -2 there, 5 there. Right now, all of them have the same multiplicity. They all have a multiplicity of 1 right now. I asked for all different in a degree of 8. So they need to be 3 different numbers, and they need to add up to 8. So I'm going to have about 1, 2, because those are different numbers, and now they have to add up to 8, so 1 plus 2 is 3, and 5 more to get to 8. And that's it. I have done all the stuff that I was asked for. Let's repeat this process for number 2. Number 2. This was number 1. Number 2. I want zeros of x equals 1/2, -2/3, both a degree, no, both, both multiplicity of 2, and therefore degree 4. Therefore degree 4, and a leading coefficient of -72. Whew. Okay, so if we use our definition straight up, creating the zeros themselves should not be too much. So I'm going to leave a blank spot for this coefficient because I really don't know what that is yet. And that's because these are fractions. Whenever those are fractions, that coefficient needs to happen at the end of the problem. So this 1/2 is going to create a factor of 2x minus 1. Again, the easiest way to do that is it's going to be this guy x minus that guy. Maybe you could draw little arrows for yourself while you're doing it. You know, you can just say, okay, where'd this guy come from? Well, here's x equals 1 over 2. It is this guy times this guy minus that guy. You know, make it a little loop for yourself of some kind. That way it's easy to create this, so you don't have to think too much. Likewise, this other 0 is going to be 3x, and minus a negative is a plus 2. And these both get squared. Okay. Now we have a leading coefficient of negative 72. First of all, this 2x is getting squared. That 3x is getting squared. So that 2 squared, that's like a 4. That 3 squared, that's like a 9. That overall, 4 times 9 is 36. But we want this to be negative 72. So what number times 36 is negative 72? Turns out that you need to multiply by negative 2 in the front. It's a little bit of guess and check, a little bit of annoying. Questions like this, I just want to let you know, are not going to show up on a test or a quiz. It's more so for you to be thinking about the whole process here. And if you're able to think about all these moving parts, life can be a little bit easier. The previous examples were the ones that would show up more likely on a test or quiz, are the ones you'd have to do. I guess a college class could make these on a test or quiz, although I have not seen them myself. Let's try it out on number 3. So, number 3. We got, I'm just going to write z because I'm getting lazy here. We got zeros of x equals 1, 2, negative 4, odd multiplicities, degree equal to, oh, it says 5 in the question. You can't do that. You can't have all odd multiplicities. Oh, yes, you can. Yes, you can. Degree equal to 5. Okay. Yes, you can. And an even leading coefficient. Even lead coefficient. All right. So, if you want to, try to pause it. Otherwise, you can just watch for the rest, next part of it. Maybe it's getting a little bit too rough for you, too annoying. And life goes on if that's the case. So let's go for it. I'm going to create a new letter. How about R? R of x equals, I don't know why I changed colors. I just did. So we have R is, we have a blank spot for my leading, actually it says even lead coefficient. How about a 2? Awesome. All right, and then we have x minus 1, x minus 2, and x plus 4 as our 3 different factors given our 3 zeros here. We want an odd multiplicity. So the odd multiplicity, every single one of these is odd. They're all odd right now, but they don't have a degree of 5. So if I just change one of them to be a 3, now it's 1 plus 1 plus 3. Great. Now my degree is 5. We're done. That's the whole question. Not too terrible. We have 2 more examples to do. I'm not going to totally kill paper here. I'm going to do it over here because it's not that bad of writing over it. Life will go on here. So this one I want zeros of 0 and pi. I want even multiplicity. I want a degree equal to 6 and a fractional leading coefficient. Fractional leading coefficient. Okay. So again, pause if you want to try it on your own. Would be a good idea. Do recommend it. See if you can figure out a question here on your own. We'll do f of x equals, and you could write x minus 0 here if you wanted to. You don't have to write x minus 0 because I would actually just write an x. And then a pi means x minus pi. They both have an even degree, but it's even m, so we could write 2 and 2, but if we did that, we wouldn't have a degree of 6. So how about 2 and 4? That would give us a degree of 6. And this is a fractional leading coefficient. How about a half? Boom. Nice and simple. Lots of different correct answers there, by the way. Didn't have to be that way. You could have had a 4 there and a 2 there. Could have had a 2/3 in front. One last example. And you know what? It's been 30 minutes. I'll call it quits for this video, and we'll just make a third video for it. That one will include the homework. Make you guys happy. Do less work. There we go. So number 5, our last example for the day. We got zeros of, let's see, what's the problem say? We got x equals 2 over 5. We have -3 over 4. I said any multiplicity degree equal to 3 and a leading coefficient equal to 200. Okay, so this one's a tough one, so if you really want to try it on your own, you can, or you can just watch. It's our last one for the day. How about h of x equals, leaving that leading coefficient blank because we got fractions, 5x minus 2 and 4 x plus 3 as our zeros. It says any m but even degree, so I gotta square something. I would rather square a 5 than square a 4, so I'm gonna pick this one. And now it says we want to have a leading coefficient of 200. So to have a leading coefficient of 200 here, well, this guy here is 25, and this one's a 4, which means that the whole thing ends up being multiplying to 100, which means a 2 comes out in front. Please note, if you decided, and you were doing this on your own, and you decided to make the other one the 2 here, and again, the reason why we made that a 2 is I wanted the degree to be 3, so 1 plus 2. If we did it that way, well, now this would have a 5, and this would be a 16, and 5 times 16 is 80. So to make it multiply from 80 up to 200, you actually have to solve a little bit of an equation, because nothing really multiplies nice and neat up to 200. It turns out that 80 multiplied by x equals 200, and if you solve this guy, you end up getting 2.5, or x equals 5 over 2 as your division if you have the fraction. So you end up with a 5 over 2 here in front. So those are the 2 possible correct answers to this question, but I do think this one is a lot easier to deal with. Alrighty guys, hopefully that wasn't too terrible. I apologize for honestly, I don't think that was my best version of a video. Maybe I talked too fast or something like that. But when we have actual practice problems of these, you know, the ones you'll actually have to do, I'm promising you they're not going to be this hard. I just wanted to get the ideas across to you for when they start mattering a lot, because they will eventually matter, especially for what's coming up the next part of this lesson, which is called the end behavior. Okay, well, have a great rest of your day, guys. Great weekend. I will see you for your next video on Monday. Have a good one.